Hi everyone, Mrs. Baxter here, and today we are going to be expanding on our equations by talking about inequalities. Now, when you think about the word inequality, if you think about equal right here, and the word in means not, and then equal, we know what that means, right? Equal is that, and it's not equal. Okay, so we're talking about things that are not equal to each other or can be greater than or less than, and what it would look like on a graph. And really, when we say graph, we're talking about a number line. Okay, so inequalities have these four symbols, right? We've got greater than, we have less than, we have greater than or equal to, or we've got, let's do another color, nice pretty blue, less than or equal to. Okay, so those four. Now, if you remember back to, elementary school when we first learned about these, this is greater than, which really means that the number on this side is bigger than the number on this side. Okay, and we probably remember the little alligator. Okay, we got this cute little alligator here, and it wants to eat more of whatever's on one side. Okay. But one of the things I like to tell people is that, because you know what, when I was in elementary, I could not remember which sign was which. Is it greater than or less than? How do you tell? Well, when you're looking at the numbers, so let's see, 3 is greater than 0, right? When you're looking at the numbers, we read from left to right, correct? So if you're reading the math problem, you'll know the sign based on where it's pointing. So if 3 comes first and it's bigger, you say 3 is greater than 0. All right. If I say 2 is less than 5, notice I'm reading left to right. Okay, so that hopefully will help you a little bit. Now, the reason why we don't do this, we want to simplify it. And so that's why we only have less than or equal to, means that it could be the same. So we could have 0 is less than or equal to 0. That would be true. Okay. We could have -2 is greater than or equal to -2. That would also be true. So keep in mind, in order for that equal, the two numbers on the both sides, or the equations on both sides to be equal, you have to have that line under the inequality. Okay, so let's look at a couple examples here really quickly. And I have 2x plus 1 is less than -3. Okay, so 2x plus 1 is -3. Let's solve for x. And we do this in the same way we've been solving basic equations. Now, a lot of us, I teach to put a little line down where the equal or inequality is so that you can balance your equation. So whatever you do to one side of your inequality, you have to do to the other side of your inequality, just as you would if you had an equal sign right there. Okay, and then for those of you too who might remember, we are still going to follow the basic PEMDAS rule, where if you don't know, if you have an variable where you don't know all of the numbers, you're going to start solving your problem from this direction up. So the very first thing we're going to look for is, does this equation have an addition or subtraction problem? It sure does. It has one right here, okay? And sometimes you might see it like this, where it's 1 plus 2x. Either way, you still have an addition problem, right? So we find out we have an addition problem. Let's do the opposite, and we're going to subtract 1. Now, the reason why I chose -1 is because you have this x tied to a 2. It's multiplied together. Can't do anything with that yet, okay? So let's get the 1 away from the x. Subtract from both sides, and I'm left with 2x is less than -4. Now, something I've been noticing is when you add two negatives together, make sure that your negatives are getting bigger. Okay, so it's like saying -3 plus -1. That's what we're doing. So we're going to get a bigger negative, which is -4. Now, going up the PEMDAS scale, I've got a multiplication problem here, and I want to get the number away from x. So let's divide by 2 on both sides, and I'm left with x is less than -2. Now, this is x is -2, but the problem is asking us whether or not the solution the number is a solution to the inequality. Okay, so go ahead, and what we're going to do is we're going to test this out. Let's plug in -1 for x. Okay, is it less than -2? That's my question. Well, if you're looking at a number line, and I do 0, -1, -2, -1 is actually bigger than -2. So this is false. -1 is not smaller than -2, okay? All right, let's look at the second one. Let's plug in -2 for x is less than -2. Well, we don't have this equal sign here, so this also is false and not true, okay? All right, let's look at number 2, and I'm going to go a little bit faster on this one. All right, so 7 is less than or equal to, this time, 3 minus x. Well, I have a subtraction problem here. I'm going to get my number away from my letter. I'm going to subtract 3 from both sides. This becomes 0. This becomes positive 4 is less than or equal to negative x. Well, I can't have a negative x. It's almost like saying I have -1 times x. So I have to divide both sides by -1. And something to keep in mind is when I divide by a negative, I need to flip the sign. So this is going to flip this way, and I'm left with -4 is greater than or equal to x. Okay, so write yourself a little note here. This is important. When dividing by negatives, comma, flip the inequality. Okay, this is important. You're going to see this on the homework for sure. All right, so let's test this now. All right, I'm going to plug in 2 for x, and I'm going to say, is -4 greater than or equal to 2? Question mark. Nope, this is also false. -4 is definitely smaller. 2 is bigger. All right, now let's plug in -4 for x. And I have my original is -4 is greater than or equal to, oh, look at that, -4. Is this true? Well, yes. Since I have this right here and it's also equal to, this one is actually true. True. Yay. Okay. So now how do we graph this? How do we represent this and look at the solutions on a number line? So rather than testing for individual solutions, so does 5 work? Does 100 work? Does 2.5 work? It's more common to represent all the possible solutions using a number line. So one thing I want you to look at here is, what do you notice that's different between these 4 equations and these 4 graphs? Well, if you noticed, the first thing a lot of people notice is the open circle here versus a closed circle. Okay, that's important to note. But then also noting that these first 3 here have your variable first, and this one has your variable second. Now, some people immediately go, oh, look, when the variable comes first, the inequality goes like this, so does my arrow. Okay, but your variable has to come first, because look what happens here. When your variable comes second, ooh, we're going the opposite direction. Okay, so if you remember that the rule is the variable comes first and you go in the same direction, you'll be good. Okay, if you need to flip this around, you can do x is less than or equal to -2. Okay, so flip your equation, flip your sign around, and then now look. Oh, yep. X, which is all of this, is less than or equal to -2. Okay, now let's talk about your open and closed circles. When you're doing your graph, make sure, in this example, we have an open circle. Open circles is when you have greater than or less than inequality signs only, okay? A closed circle So a closed circle is going to be greater than or equal to or less than or equal to. Now the reason why is because when it's an open circle and it's greater than or less than, it does not include that number. It's either less than or it's greater than, but it's not 1. Okay? But when you look at a closed circle, it's got this equal to sign, and so that's the trick. So in this solution, I'm saying that all possible numbers, including 0, are part of the solution. Okay? So if we look at this one right here, f is greater than -3. Here's -3. It does not include -3, but it's all the answers above it. Okay? Same thing with -2 is greater than x. We can start at -2, and it includes it because it's equal to -2 as well, but it's also all the solutions less than that because -2 is greater than all those solutions. Okay? All right, so let's do some quick examples here. All right, in this example, y is greater than or equal to -2. The first thing I would do is figure out, well, what's my symbol? Am I open circle or closed circle? If you said closed circle, good job. Okay, so let's find -2 and create a closed circle. And when I'm looking at it, it says y is greater than. So all my solutions are going to be greater than -2. Greater than or equal to, sorry, -2. Okay? So your graph is going to look like this. All right, let's look at number 4. Now, 3 is greater than b. So first of all, I'm determining I'm going to have an open circle. So I'm going to find 3, do a big open circle. Oops, wrong pen. Big open circle. And then I'm going to say, oh, 3 is greater than b. So you got to think about this. Okay, 3 is greater than b, which means b is less than 3. All of these solutions. And the reason, if you guys know, the reason why you do an arrow is because this goes to infinity. Okay, it does not stop anywhere. So make sure you include your arrows. Okay, flip over to the back of your worksheet. Here are your notes. And here we're just going to do some solving. Okay, so we'll get a little bit of practice here and I'll show you some possible solutions. All right, on this one, let's zoom in here. I'm going to do my little lines down here so that I make sure what I do to one side, I do to the other side, okay? And when I'm looking at the side with my x right here, I want to say, oh, I've got to get that -1/3 away from it. Well, there's 2 different ways I can solve it. I can either divide by -1/3, or I can split this up a little bit and do multiply by 3 first on both sides, okay? So then I get -6 is greater than or equal to -x. See, I get rid of those. So I'm left with -1 times x, which is -x. Don't forget the rule now, because I'm going to divide by 1 on both sides. I have to flip my sign. And so now I'm left with x is equal, negative divided by negative is a positive. This is my answer for this problem. Make sure you flip your I'm not going to say sign. Flip your inequality. Okay, don't forget. All right, let's look at this problem. This one's a little more complicated, but you can do it. All right, so we're going to draw a little line here. One thing that you're going to do first before anything else is simplify both sides. Simplify both sides first, okay? And what I mean by that is, can I do anything here to simplify it? Nope, 9 and 2x, we can't add those together. They're 2 separate terms. If this had an x, sure, yeah, then we can combine that, but it does not. Over here, I'm seeing 7 plus 2 times x and 7 plus 2 times -3. So here we have to rainbow this out and then simplify, okay? So distribute first, and then combine like terms, okay? So I'm just gonna bring my 9 plus 2x down and all the way to 7. And now I'm going to go plus 2 times x, which is 2x, minus 6, because 2 times negative 3 is 6. Well, I'm looking at this and I go, ooh, I can combine those two. So let's do that. And if you have to write all this out, which I highly recommend, it makes it much easier. Okay, so what I did was I combined 7 and negative 2, and I got 1. All right, now what you're looking at is where am I going to put my letters and numbers? So let's say I'm going to bring my numbers to this side and my letters to this side, okay? So that means I have to move things over. And so I'm going to start by negative 1. So I've got 8 plus 2x is less than 2x now, okay? But this is looking kind of funny. Negative 2x, right? What happens? 8 is less than 0. Well, that's not true. No, that can't happen. So this is a no solution problem. And you can do this as well. Okay, so this is the answer to number 6. You will have that happen sometimes. All right, let's get some more distributing practice. Let's simplify the left side of this problem because I'm seeing this right here, okay? Then we'll separate and get the n by itself. So let me make sure I drop my equals down. 6, and then negative 4 times 6n is negative 24n. Negative 4 times 7 is negative 28. Remember, negative times positive is negative. And 122. Okay, well, I'm looking at this and I'm going, oh, look, I've got like terms right here. And when I combine those together, I'm going to get negative 24n minus 22 is 122. Then I'm going to add my numbers to both sides. And I get negative 24n is greater than or equal to 144. Now, if you plug this next piece into your calculator, because I have these two together here, this is a negative 24 times n, so I have to divide both sides by negative 24, and I'm left with net n is, don't forget, flip your signs, greater than or equal to negative 6. Okay, so I'm going to do another reminder. Burp. Flip your sign. Okay, don't forget to flip. This is what's going to make you flip. Flip, flip. All right, last problem. Lots of 3's in here, so don't let that get confused. Don't let that confuse you. If you need to do what I do, where I draw my little lines to show where I'm distributing, please do. It's okay. All right, so we're going to distribute this side right here first. And I'm going to go negative 3 times w is negative 3w. And negative 3 times negative 3 is positive 9. And I have this. I'm just going to carry down. Now I'm going to do negative, oops, woo, sorry about that. Negative 9. Oh, huh. Look at that. These become 0, and I'm left with negative 3 is less than or equal to negative 3, w, like this. I could keep going, but because I have this inequality here that says less than or equal to, and these are the exact same thing, I already know that this is true, okay? This is true. We are kind of done here, all right? W, when you solve this out, W is going to be greater than or equal to W, right? And if you leave it like this, that's fine. Either answer I will be okay with, all right? So really, this means all solutions, right? So W is greater than or equal to W. All right, let's do this word problem. It's kind of tricky, so we'll go through it together, okay? When I look at this, it says, of 8 puppies, there are more girls than boys. How many girl puppies could there be? So this is kind of one of those logic problems that we need to think through. The biggest piece of advice I have is to make sure that you label your different variables, your question marks, basically. So I'm looking at this and I go, oh, okay, we have girls we have boys. And the question is asking how many girl puppies could there be, okay? And in total, we have 8 puppies. Okay, we have 8 puppies. So how can we create an inequality with this? Well, in my brain, I go, okay, well, let's see. Let's make X, let's use a different color, like this color. X is equal to girls. Y is equal to boys. Those are 2 different variables. And I know that when we add up our X plus Y, it's going to be less than or equal to or less than 8, right? How many, of 8 puppies, there are more than girls than boys. And so really 8 is greater than or equal to X plus Y. And then it's like, how many girl puppies could there be? Well, if we're thinking about it, and there has to be more than how many girl puppies, right? What number is that? Well, if there are more girls than boys, can I have 0? No. Because if I had 0, then there'd be 8 boys. So then if I have 1 girl, I'd have 7 boys, and so on. And so when you look at the halfway point, if I had 4 girl puppies, that means I'd have exactly the same number of boy puppies, which is 4 boy puppies. But X has to be greater than 4, right? In order to have more girl puppies than boy puppies. So I'm looking this and I'm going, okay, well, I have 8 puppies, which has to be greater than the number of girl puppies, which has to be greater than 4. So this right here would be how I would write this inequality, is that 8 puppies is greater than girl puppies, which is greater than 4. All right. That's a very simple talk through of that. We will get more practice in the homework assignment. I'm going to do a little preview of what's coming, not tomorrow, but the next day, or not today, but the next day or the next day after, depending on how much we get through. But when you see an equality like this, like the word problem we just did, this is kind of like what we're trying to solve, right? We have 5 puppies, and then we have 3x plus 1 in the middle, and then 8 on the other end. Well, it's just saying that 8 has to be our biggest number. Do you follow? So 5 is the smallest. There's some number in here, we don't know what it is, that it could be, okay? But it could be a range of numbers somewhere. So let's solve this problem, okay? Well, when you do this, you're going to split into 2 equations. Okay, so split it into 2 equations. So on one side of my paper, I'm going to go 5 is less than or equal to 3x plus 1. And on the other side, I'm going to go 3x plus 1 is less than 8. So I'm going to take the first one and create a problem like this. And then I'm going to create a second problem with the second half of this. All right, let's do this really quick. And then I'm going to divide by 3. So now I have 4/3 is less than or equal to x. Yes, you could change that to 1 1/3. Either way, I would be okay with this, okay? Now let's go to the second problem. And let's say 3x is less than 7. If I divide both sides by 3, x is less than 7/3. Now, notice, this and this are both going in the same direction. So guess what? We're going to put these 2 together. Watch what I do. I take my one equation, 4/3 x, less than or equal to x. Oh, wait, sorry, my bad. This is not an x. 4/3 is less than or equal to x, which is less than equal to 7/3. So do you see how I put all of that together? Lovely, lovely, right? So I took this one. Here, we put them together just so that you can see. You have kind of 3 different answers. And then what we'll do is we put them together at the end. All right. All right. I know that was a ton of notes for today, but if you have any questions, please let me know. There is going to be a homework assignment, and you guys will be great. You'll do fine. Use your notes to help you solve the graphs and solve your problems. All right. Thanks. Have a great day.